Hello, welcome to the next video lecture on strength of materials.
Now we know to find out the normal and shear stresses on an arbitrary plane which is inclined at theta angle to vertical line. Sigma theta is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. This is the equation for normal stress on the arbitrary plane. Similarly, tau theta, shear stress on the plane, given by minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. And we also know how to calculate principal stresses. When we combine sigma 1, sigma 2, we can write it like this: sigma x plus sigma y by 2 plus or minus square root sigma x minus sigma y by 2 whole square plus tau xy square. We can also find out the angle of principal planes. We have the equation theta 1 is equal to half tan inverse 2 into tau xy divided by sigma x minus sigma y. That is one of the principal plane. And the other plane is just obtained by adding 90 degree to it, because we know that two principal planes are mutually perpendicular. Then we have derived equation for maximum shear stress, tau max, which is plus or minus square root sigma x minus sigma y by 2 whole square plus tau xy square, and theta tau max of tan inverse minus sigma x minus sigma y divided by 2 into tau x. First problem: a point in a strained material is subjected to a tensile stress of 500 megapascal and 300 megapascal in two mutually perpendicular planes. Calculate the normal, tangential, resultant stresses and its obliquity on a plane making an angle of 30 degree with the axis of second stress. Also find the principal stresses, their orientation, maximum shear stress and its orientation. See, he says it has a point, but the point can be enlarged and viewed as a square or rectangular shape. That's what we are doing. I have drawn here. This is actually representing a point. But he says it is subjected to tensile stress of 500 megapascal and 300 megapascal in two mutually perpendicular planes. He is not telling which is sigma x and which is sigma y. So we can take 500 as sigma x or 300 as sigma x, whichever is convenient. Let sigma x as 500 megapascal. Sigma y, I will take it as 300 megapascal. And also observe that they both are tensile stresses, so I have to use positive value. And he has not given any detail for shear stress. So let us take tau xy is 0. This is sigma x, this is sigma y, and this is tau xy, which is 0. So what we have to find out? We have to find out normal, tangential, resultant stresses and its obliquity on a plane making an angle of 30 degree with the axis of second stress. Axis of second stress means sigma y. First stress is sigma x, second stress is sigma y, and the axis means this is the axis of second stress. And the plane is making 30 degree with this axis, means plane is somewhere here. As I say, this is the plane. And 30 degree positive angle means it should be measured counterclockwise like this. So this is what is theta. On that plane, I have to find out normal stress. Normal stress means sigma theta. Tangential stress is nothing but the shear stress, tau theta. Resultant stress means sigma suffix r, and obliquity means phi. This is sigma theta. Now we will substitute the values. This is given by sigma x, which is 500, plus sigma y 300 divided by 2 plus 500 minus 300 divided by 2 into cos of 2 into 30 plus 0. Tau xy is 0. This, if you calculate, you will get 450 megapascal. That is the normal stress on the given plane. This is the equation for shear stress on the arbitrary plane. Let us substitute. This is equal to minus 500 minus 300 divided by 2 into sine of 2 into 30 plus 0. So we have to find out this. You will get it as minus 86.6 megapascal. So we have found out the shear stress also on the given plane. Now we have to find out the resultant. Resultant sigma r is vector summation of these two. So sigma theta square plus tau theta square. So just calculate the resultant. Resultant, you will get it as 450 square plus minus 86.6 whole square. This, if you calculate, 458.25 MPa is what you get. This is the resultant stress. The angle of obliquity means phi. In what direction this resultant is acting, that can find out. Phi is equal to tan inverse of tau theta divided by sigma theta, equal to tan inverse tau theta is minus 86.6 divided by 450. Comes out to be minus 10.9 degree. So we have obtained the solution for the first part. Next part is find the principal stresses, their orientation, maximum shear stress and its orientation. So all that we have to find out. This is the principal stress equation. Let us substitute the values here. This is equal to 500 plus 300 divided by 2 plus or minus square root 500 minus 300 divided by 2 whole square plus 0 square. 500 plus 300 is 800, by 2 is 400. So 400 plus or minus 500 minus 300 is 200, by 2 is 100. Square root of 100 square is 100. So this is 100. So sigma 1 is 400 plus 100, which will be 500. And sigma 2 is 400 minus 100 is equal to 300. Observe that sigma 1 is equal to sigma x and sigma 2 is equal to sigma y. Why we are getting like this is tau xy is 0 here. We will find the angle theta 1. We'll substitute the values for this. This is equal to half tan inverse 2 into 0 divided by 500 minus 300. So it is in the form of tan inverse 0. Tan inverse 0 is 0. Theta 2 is equal to 0 plus 90, which is 90 degree. Sigma 1 is coincident with sigma x, so it has to be inclined at 0 degree. And sigma 2 is aligned with sigma y, so it is 90 degree to sigma x. We can find out tau max now. Tau max equation is here. We'll substitute the values. Plus or minus square root 500 minus 300 divided by 2 whole square plus 0 square. The tau max will be 100 megapascal. And the angle for this tau max, theta tau max, this is actually equal to half tan inverse minus of 500 minus 300 divided by 2 into 0. So it is actually tan inverse infinity, right? Anything by 0 is infinity. So tan inverse infinity is 90 degree, should be 45 degree. This is the inclination of maximum shear stress. Next, coming to this problem. The state of stress in a two-dimensionally stressed body is shown. Determine the principal stresses, principal planes, maximum shear stress and corresponding planes. Also find the normal and shear stress on plane 45 degree as shown. So here sigma x is compressive in nature, so it has to be taken as minus 120 now. Similarly, sigma y is also compressive, so it has to be taken as minus 80. And tau xy is given as 60 Newton per mm square. There are only two possibilities for tau xy. One is opposite vertical faces forming a counterclockwise couple, but it cannot exist only like this. There will be complementary shear also like this. This is called positive tau xy. And the other possibility is the opposite of this, where opposite vertical faces will have a clockwise couple like this, and for balancing couple you will have shear stresses like this. This is taken as negative tau xy. So whether the given tau xy is positive or negative is decided by this sign convention. So according to this convention, in the given problem now, shear stresses on opposite vertical faces are forming clockwise couple, so it has to be negative. So sigma x, sigma y, tau xy, all three are negative in this problem. And also the angle that is given for the plane, I'll call this plane as AB. Plane AB is inclined at 45 degree to vertical in this direction, but this measurement is actually a counterclockwise measurement. But how we normally measure the plane? with a vertical reference. See, I'm drawing a vertical reference here. I'm just drawing a dotted line. That is a vertical reference there at B. Now, if I measure counterclockwise direction, that becomes theta for me. This is actually theta. So positive angle is always measured like this, counterclockwise from the vertical. So what it will be? 180 minus 45, 135. Like this, you have to carefully find out sigma x, sigma y, tau xy, and theta. So we will use the equations now. Sigma theta. I will substitute the values. Here you see sigma x is minus 120 and sigma y is minus 80 divided by 2 plus minus 120 minus of minus 80 cos 2 into 135 plus tau is actually minus 60 into sine 2 into 130. Calculate this, it will be minus 40. So this is the normal stress on the plane AB, which is inclined at 135-degree positive angle with respect to the vertical line. Now we'll calculate what is the value of tau theta. Tau theta equation is this. This is equal to minus 120 minus of minus 80 divided by 2 sine 2 into 135 plus tau xy. Tau xy is minus 60 into cos 2 into 135. If you calculate this, it comes out to be minus 20 Newton per mm square. So we have found out normal and shear stress on the plane. Resultant is not asked in the question, so you don't have to calculate that. We have to find out the principal stresses, principal planes. Finding principal planes means finding theta 1 and theta 2. So let us find principal stresses first. Okay, let us substitute the values. Sigma x is minus 120, sigma y is minus 80 divided by 2 plus or minus square root sigma x minus of minus 80 divided by 2 whole square plus tau xy. Tau xy is minus 60 whole square. So this you have to calculate minus 100 plus or minus here comes out to be 63.245. So now we can find out what is sigma 1. Sigma 1 is what? So sigma 1 is minus 100 minus 63.265. So it comes out to be minus 163.3 Newton per mm square. And sigma 2 will be minus 100. Sorry, first one is just here. So it comes out to be minus 36.7. And the second one is with minus sign. Minus 63.245 comes out to be minus 163.3 Newton per mm square. So both the principal stresses we have found out. Let us find out principal planes. Theta 1 as of tan inverse 2 into minus 60 divided by sigma x is minus 120 minus of minus 80. So if you calculate this, comes out to be 35.8 degree and theta 2 is 35.8 plus 90, which will be 125.8 degree. So we have found out the orientation of principal stresses also. Now we have to find out what is the maximum shear stress and substitute the values. This is plus or minus square root minus 120 minus of minus 80 divided by 2 whole square plus minus 60 whole square. Calculate this. This you will get it as plus or minus 63.25 Newton per mm square or megapascal. That is the maximum shear stress. Now we'll try to find out what is the maximum shear stress in orientation. We'll substitute half tan inverse minus of minus 120 minus of minus 80 divided by 2 into minus 60. I'm writing each and every step substitution also because this is where you make mistake. See the sign minus of minus 120 minus of minus 80. If you miss one sign here, you will get a different answer. So you have to be careful here. And you will get an angle of minus 9.217 degree. This is the orientation of maximum shear stress. We'll take up one more problem. Now the difference here is he has not given sigma x directly. You have to calculate sigma x first. See, sigma y is straightforward. It is 40 MPa. So we have to resolve this 60 MPa stress into two components like this. One component will be like this. This is sigma x actually. And the other component will go for shear stress because it is on the vertical plane here. Similarly, on the other side also I can write like this. This becomes sigma x and this becomes tau x. So when you resolve the given 60 MPa, sigma x becomes 60 cos 45 and tau xy is 60 sin 45. 60 cos 45 is 42.426 and this will also be same 42.426 Newton per mm square. And observe the opposite vertical faces are having shear stress which is forming counterclockwise couple. So shear stress tau xy is actually positive. And even sigma x is tensile in nature. So that is also positive. And sigma y is already given. That is also tensile. So that is positive 40 MPa. And the plane AB, it is having an inclination of 30 degree with vertical. And that itself is theta. This itself is theta. So that is the counterclockwise measurement from the vertical there. I want you to do this. Answers also I'll give. Now answers you should get sigma theta as 78.6 MPa. Tau theta, you get it as 20.1 MPa. Sigma 1, you should get it as 83.7. And sigma 2 you should be getting 1.2 MPa. Theta 1 should be 44.2 degree. Theta 2 should be 134.2 degree. Tau max should be plus or minus 42.4 MPa. And theta tau max should be minus 0.8 degree. These are the answers you should get. You please try to solve this. This is another problem which you can try. Here also I will give you the hints. Observe the theta is given here with respect to horizontal. If this is 30 degree, what will be this angle? This will be 90 plus 30. This will be 60 degree. But what we want is measurement from here, from vertical and counterclockwise measurement like this. This angle is what is required. That angle will be how much? 120 degree. Or if you want to take this 60 degree, that is also fine, but you have to take it as minus sign. So hint is theta is equal to plus 120 degree or minus 60 degree. Counterclockwise measurement also you can use, but you have to use minus sign there. And of course, sigma x is compressive here, so minus 30. And sigma y is tensile, so plus 120. And tau xy, the opposite vertical faces forming clockwise couple, which is negative according to our sign. So minus 40 MPa. With this, you can find out the answers. You should get sigma theta as 117 MPa, tau theta as minus 45 MPa, sigma 1 as 130 MPa, sigma 2 as minus 40 MPa, theta 1 you should get it as 14.03 degree, theta 2 will be 104 degree, maximum shear stress should be plus or minus 85, and theta tau max minus 29 degree approximately. Find out the exact value.